Good day, my name is Ruud Willekes and this is a short click-through demo of the strEAM Plus Asset Performance Management Suite fully integrated in Maximo. As you can see, this fully integrated module consists out of a number of applications, reports and dashboards. And to begin with the dashboard, you can see how that we have integrated the data from Maximo and strEAM Plus and put them in a number of KPIs and result sets. The first KPI gives you a number of the potential cost reduction on maintenance, which is calculated by the number of unnecessary PMs that do not lower the criticality of assets. We extrapolate this for the next 12 months in terms of labor and spare parts, and that gives you a amount of money which can be saved on your maintenance budget each year by focusing on diminishing the amount of unnecessary maintenance. So this number already gives you a business case for implementing the solution. The next result set shows you which highly critical assets do not have a PM attached to them. So that one is, those are assets that need your immediate attention because if these assets fail, they have a very high impact on safety or production. The third result set shows you the PMs on non-critical assets. So these are the PMs that lead to the amount of money in the top KPI. So these PMs are on assets that do not have a high impact on safety or production or quality or whatever business objective that you have. And they probably the frequency can be lowered or they can be deleted altogether. If I scroll down a bit, I see that you can see that you can also put criticality over the work orders in your backlog. So you can see how many safety critical work orders are in backlog. So those are usually the work orders you prioritize the highest. And you can also see in the result sets which work orders are safety critical in backlog or work orders who are critical on other business objectives apart from safety. So this gives you a really nice overview to prioritize in your backlog which work orders should come first. And the last two portlets give you an overview of the progress of your RCM risk analysis. So you can see how much assets you still need to analyze based on risk. So this is of course just an example of a dashboard, and this can be fully configured down to the user level of each specific role in your organization, like a maintenance manager, a reliability engineer, a technician, a safety officer, or a planner and scheduler, who can all benefit from this data that we generate and the combination of the strEAM Plus data with the existing data in the Maximo database. So if I start with my risk analysis, we usually supply the customers with some kind of a bad actor report. Again, this is an example for a specific customer, but there are more options to do this. So before you start with the risk analysis, you need to know where your biggest problem areas are. So at this point, there is no risk analysis in place, but we only have data based on cost. So in this example, we see for a customer we have broken down all the assets into different asset types, and we see to which particular asset type the biggest amount of money in your maintenance budget goes. So that could be an indication of a problem area, not necessarily, but you need a starting point to start drilling down in your data to see where to apply risk analysis first. So in this case we can drill down to the pump asset type, and there's a further hierarchy in this that shows you that the centrifugal pumps consume the largest amount of your maintenance budget. You can see that in this example the air pump breaks down a lot, so that could be an indication. If we go to the air pump in Maximo, you see that the reports are all clickable, takes you right into Maximo. That these air pumps fail very often, in this case because they're jammed, and that could be an indication something's wrong with your preventive maintenance plan. So that could trigger a risk study on these pumps, and that could be a starting point for your analysis. If we go to the actual risk analysis, is that we start working with the risk matrices, which are fully configurable. So this is just an example of one risk matrix for one particular customers, but all the dimensions of this risk matrix together with the number of risk levels are all fully configurable according to your own standards. So if I go to the actual risk analysis, I have an example for a customer. As you can see, we have multiple risk studies which can have multiple revisions. So, for example, each year you can revisit your study, make some changes based on historical data in Maximo that you gathered over the year. Make some changes and make a new revision of your risk study. In this case, you see that we have a number of data points that we put in this study. So there are a number of process steps, there's a motivation, there are some team members who are involved in this study, the operating context, all kinds of data you can put on the study. If I go to the next step, the actual analysis is done on a group of assets and or locations in Maximo, which depend on how a particular customer has made his asset hierarchy. But it can be done on multiple hierarchy levels, because of course in practice Maximo gives you the option to choose different sorts of configurations of your asset hierarchy, so we can accommodate our risk analysis to all kinds of different situations. In this case, there's a selection of assets in this particular analysis for a mobile drilling rig, just an example. And what we are going to do is that we are going to add data to all these assets, which is the actual risk analysis. So an asset, in this case, it was an air treatment asset, has multiple functions. Each function can fail of this particular asset, and if this asset fails, it can have effects on your business objectives or consequences, as you can see. So this is all comes from the risk matrix that you have made earlier in the process. Then the functional failures are caused by certain failure modes, which can also be entered in the solution. And the last step is that you can imagine this is a lot of work when you have to manually do this. but we supply this solution with a predefined content library of all kinds of data templates for different kinds of assets, also for municipality assets. So this comes with the solution as well and saves you a huge amount of time to build the analysis. So when we have entered all this data and deployed the data templates, you can review the results. All the assets in this particular study are ranked on risk, as you can see. So the assets with the highest impact on your business objectives come on top. And you can also see which failure modes lead to this very high criticality of the tank asset, for example. And the next step, if you know why an asset is critical, you need to enter some mitigations, as we call them, or risk reducing measures to bring the risk level of the failure modes to acceptable levels. So in this case, we have a predefined library as well. The tank is highly critical because a certain filter in the tank is fouling probably a lot, and if the tank goes down, that has a high impact on safety and production. So what the solution does is it proposes certain mitigation strategies that an engineer can choose from to mitigate the risk of this highly critical failure mode. So in this case, for the filter, there could be a loop test, a modification, or use another filter, or he can have the replacement, the filter on stock. So these are the three options the engineer has to choose from, and he can choose the best option for this particular tank asset. So if you have done this, this will lead to a list of mitigating tasks that you need to do, and then you have to align these to the existing tasks in your PM strategy. So here I can generate the list of all the mitigating actions, as you can see, and then I can, in the next step, align these tasks with the existing PM strategy. So in this case, there is a task in the existing PM strategy of this customer that covers the mitigating action. If not, then of course, because you're a Maximo, you can immediately add the mitigating action to the PM and then approve that the risks are all mitigated. So this will lead to a overview of all the risks that you have and if they are covered by your maintenance strategy, which we have put in a report. So here on the left side of the bar, you see all the mitigating actions that come from the risk analysis. So this particular HVAC system should be cleaned every month, and then there is an actual PM that states that there is a cleaning and visual inspection on this HVAC every month. So the user Wilson has approved that this particular risk is covered by your maintenance strategy, and you can work your way down. And if it's not approved, then you need to change something to your existing PM strategy. Here in the bottom you see two disapproved actions because the frequency of the PM is lower than the frequency that comes from the risk analysis. So there's a problem here and you need to change your PM strategy. So that's on a very high level how it works. You can also generate from the solution a spare part criticality stock proposal. So if I open this, then you can align the risk analysis outcomes with your actual safety stock and reorder points in Maximo, as you can see. So for each spare part, you can calculate from the risk analysis based on the asset criticality and how much of these assets that you have that need the spare part and how critical they are. There are certain algorithms implemented that then generate your optimized safety stock and reorder point levels. So you can see if you have too many on stock. If you have too many on stock, there's a potential cost reduction of lowering your inventory, of course. And the other way around, in red, you see that you have too little on stock, which probably will lead to downtime or safety problems. So this is also something that comes from the risk analysis. The last part I want to show is the compliance part, because now your maintenance strategy is aligned, but you also need to manage that everything is executed in time. Well, at least your most critical work orders are executed in time. We have a process designed for this in the solution, in which you can make a drill down of your whole asset hierarchy. Well, in this case, again, a drilling rig. And if there is a red light, then you can see that in this case there is a lot of red lights are overdue safety critical work orders. So if I go to this particular location, I can see there's a number of work orders that are critical. Some of them are already overdue, and one of them is still due within a week, and I can make a full drill down to each of these individual work orders. And if a work order is overdue, I can go to this work order and I can trigger what we call a deviation process, which is the only allowed process to postpone the execution time of the work order. So this is an automated process that triggers another strEAM Plus application, in which you can put in a motivation and extra measures you take because you're going to postpone a critical work order. And with all this functionality in place, you got the whole process covered, from your business objectives and the bad actor analysis to the whole risk analysis process. And then after you have realigned your PM strategy and prove that all your risks are mitigated, to this deviation process, when you measure the compliance, manage the compliance, you got the whole end-to-end risk process covered. This is what I wanted to show you, and thank you for viewing it.